Hello everybody. I'm finally on live, but I don't have a phone charger and a cable, so I still have 41. Oh, this is a new pen. Let's try this one. Oh, again new. Wow. I still have 41% of the battery remaining, so if I suddenly go offline, don't be surprised because I'm run out of power. Okay, now start asking questions. I'm waiting for your questions. Come on. Yeah, I know. You're welcome. I'm very happy to spend your Saturday night with you. Logistic regression, non-parametric. Oh my God. Well, let's look at logistic regression first. I think the best example for your logistic regression is your tutorial question. Yeah, your tutorial question. So for your tutorial question, well, let's look at logistic regression model first. So when we talk about logistic regression model, it's different from regression actually. It's called classification. So usually our dependent variable y is numerical in regression, right? So for example, in your major assignment, we are predicting your assignment marks or your final exam marks, right? So we predict your exam marks. And these marks can take any numerical value. However, for logistic regression model, sometimes our y is somehow categorical. So when our y is categorical, for example, the most common example of logistic regression application is about credit card default. So for example, y can be default or not default. So in this sense, it doesn't make any sense if you directly regress y in different independent variables. For example, x1 is your income, x2 is your savings, x3 is your age or education, many things, but it doesn't make sense. Oh, it's stuck. Why does it stuck? Oh gosh. What's wrong? Is it working? Oh yeah, great. Oh yeah, I refreshed it. Okay, yeah, refresh once and then you can get it. Okay. So in logistic regression, we have where am I now? Okay, so y is default and not default, so we cannot predict whether y is equal default or not default, but instead we can define the probability of default to be p. Okay, so the probability of default to be p. So probability of default to be p. So the probability of not being default is 1 minus p. Okay, so p and 1 minus p. All right, so for p and 1 minus p, but another problem is p has a range of 0 to 1, right? But very likely, if we do some regression and try to predict this p, we can easily get a probability of 1.5 or even minus 0.1 sometimes, right? Because if we regress p on beta 0 plus beta 1 x1 plus beta 2 x2 blah 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 plus, we are easily to get a p that exceeds 1 or below 0. So we're trying to convert this p to have a minus infinity to a positive infinity value. So here, the first thing you need to know about logistic regression is the definition of odds ratio. So I believe last week, many of you have made some bet on the horses, the Melbourne Cup, right? So if you bet something, you're probably very familiar with the concept odds. Odds means the probability, or usually we define it as R. So the probability of something happen divided by the probability of something that is not happening, right? Okay, so P divided by 1 minus P. So when we talk about the odds of being default, then it is the probability of being default divided by the 1 minus probability of being default, or the probability of not being default, okay? All right, so this is the first thing. You need to know what is odds ratio. And again, if you are given the odds ratio, you need to be able to solve the probability. So for example, the probability is if you solve R over here, it becomes R divided by 1 plus R, right? Okay, so this is probability. Right. R and yes, P. So this is the first thing, odds ratio. Now, when we have odds ratio, then all you need to know is that we construct a log of R to be our dependent variable. Because even though we have R over here, we only extend it to 0 to plus infinity, right? So the range of R is 0 to plus infinity. So sometimes we can still make some prediction if we use R over here instead of P by some independent variables, and we can make a prediction that is below 0. So therefore, we really want to make the range of our dependent variable to be the whole number range, right? So that's why we use log of R. That's why it is called logistic regression, okay? Logistic regression model. So when we use log of R, if R belongs from 0 to positive infinity, the log of R becomes minus infinity to positive infinity, right? So this is something we learned in high school. So this is pretty simple. So the logistic regression model is given by log of R, the odds of something that equal beta 0 plus beta 1 x1 plus beta 2 x2 plus blah, 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 plus beta k xk plus epsilon. So this is our odds ratio. The logistic regression. So nothing different. So logistic regression is simply to replace y by log of R. And we know that the log of R is constructed by the probability of y equal a default or equal not default, okay? Right, so this is, what is this? This is log of R, okay. So how can this be tested in your exam? This is something that you are mostly interested in, right? So in your exam, I think it's going to be very simple. So one thing, you are not required to do any kind of calculation on here. So you will be given beta 0 hat equal something, and beta 1 hat equals something, and beta 2 hat equal, well, let's look at our tutorial question together. Is that okay? Let's go and see our tutorial question. Let me check it out. Where is it? Okay. So if you are able to go back to our tutorial, the last tutorial, and we have a tutorial question regarding logistic regression. So modules, sorry, give me 1 second. Tutorial 12. Okay, so now I've got the tutorial 12 questions with me. Please look at question 2 in tutorial 12, okay? So if you go to question 2 in tutorial 12, you can see a very good example of logistic regression, okay? So now let's look at question 2 together. It says, it is going to ask whether you are going to recommend a course to your friends, okay? So y can equal 1 or 0. So 1 can be recommend to your friends, and 0 can be do not recommend, right? So basically, we can define the probability of recommend to be p, and 1 minus p is the probability of not recommend this to your friends, right? So in the question, it regress and it make a logistic regression on the odds of the recommendation on 3 independent variables. X1 is their mid-semester mark, X2 is the expected final mark, and X3 is the grade point average, the GPA. So in the question, you are given that the beta 0 hat is minus 2.583, beta 1 hat is 0.0277, and beta 2 hat is 0.0335, and beta 3 hat is 0.0041. So if you are given all of those, and you are probably asked to write down the estimated regression equation first, right? So easily, you just write down log r hat equal minus 2.583 plus 0.0277 x1 plus 0.0335 x2 plus 0.0041 x3, right? Okay, so this is log r hat, the estimated regression equation. And secondly, you are also asked to probably interpret, right? Interpret the coefficient. For example, interpret the coefficient beta 1 hat, right? The estimated coefficient, actually. So if you are asked to interpret here, again, same thing. You need to say keep what? Keeping all other things constant, all other independent variable constant, when x1 is mid-semester, right? When the mid-semester is the mid-semester mark increase by 1 mark. Then here, when x1 increased by 1 mark, it's really hard to explain how r hat will change, right? So here, keep in mind, you need to say the odds, okay, of recommending the course to others, right? The odds of recommending this course to others is expected to increase by, look at this, it's magic, okay? It increased by 2.77%, okay? So this is how the log works, okay? So when x increased by 1, the log of r hat increased by 0.0277, and r hat, the odds, will increase by 2.77%. So if you learn finance, this is actually continuous compounding thing, right? So when this guy increase 0.0277, actually log of r hat will increase by 2.77%. But if you haven't learned finance, it doesn't matter. Just remember 2.77%, okay? All right, now interpret the coefficient of beta hat. Now, thirdly, very easy prediction. So you need to predict whether this student will recommend or more likely to recommend this course to others or not likely to recommend this course to others. So in prediction, you probably given, for example, beta 1 hat, the mid-semester mark is 60 and final mark is 72, and the GPA is, for example, 3.8, okay? So when you plug in all those numbers into the model, you will probably calculate an estimated of log r hat. So if you do a quick calculation, I can't do it, but suppose that I do some calculation and got a log r hat of 2, okay? So I just make up this number. This is not the exact calculation result, okay? But somehow you can plug in all these numbers and calculate one number, right? So log of r hat is 2. So you need to solve the odds. The odds becomes what? The odds becomes e to the power of 2, right? So the e to the power of 2, oh my god, I don't have a calculator. Oh gosh. Anyway, e to the power of 2 is r hat. Then you're given r hat, you need to calculate p hat, the probability of being recommending this course to others. So p hat is now given by e to the power of 2 divided by 1 plus e to the power of 2. So it's r hat. It's, where is it? Oh, where is it? Oh, it's here, right? So this is what we just discussed, right? P equal r divided by 1 plus r. So here we have p hat equal to r hat divided by 1 plus r hat, right? So in this way, we can calculate a p hat. So let's do a quick, for example, this is 3, so it's 8 point something. 8 point something divided by 9 point something. So it must be 90 something %, right? So if you are getting a student with a mid-semester mark 60 and final 70 and GPA of 3.8, the probability of this student recommending this course to others is 90 something %, okay? All right, so that's it. So this is basically how the logistic regression can be tested, okay? And it's not that hard, right? Just do it and look, you'll be given, definitely be given all the estimations, and it's all about how you understand logistic regression, okay? All right. Well, let's see other questions. Oh gosh, so many questions stacked over. So the first question is logistic, and the second is non-parametric. Okay, for non-parametric, you've already been tested in mid-semester exam. I mean the assignment, right? So don't be panic. And I think in the exam structure, there's no big questions in non-parametric. So if you really want to know non-parametric, but I can. Okay, revise non-parametric. So for the non-parametric, I think in my assignment feedback, there are already some. I mean there are already. What is that? Okay, the solution to the non-parametric questions, right? So it's all about ranking things and calculating some distributions, right? So here I can give you a summary of all parametric tests and non-parametric tests. So we have paratest and non-parametric tests. And we know the difference between the parametric test and non-parametric test is that the parametric test will use the data, right? The value of the data, the numerical value of the data. But for non-parametric test, they will use the rank of the data, right? So, which one do you think will cause a loss in the information? Definitely non-parametric tests, right? So we will lose information if we use non-parametric test, right? But what is the benefit of using non-parametric tests? We do not need to use. We do not need to assume any distributions, right? No requirement on population distribution. So this is the difference between parametric test and non-parametric test. So we lose information, but the gain is that we do not need to have any assumptions on the population distribution. No assumption, right? No assumptions on population distribution. But for parametric test, we always need to assume the population need to at least follow a normal distribution, right? Normal distribution, okay? Now, parametric test, non-parametric test. So for different purposes, we have different kind of tests. For example, if we want to test two independent populations, okay? If we have two independent populations, for parametric test, we need to use the t-test, and non-parametric test is Wilcoxon rank sum test, right? And you can read your slides. I think it's pretty straightforward, but and if you can't understand your slides, you can go back to my assignment feedback, okay? And for two match pairs or two dependent populations, we have paired t-test, right? Paired t-test. And for the non-para ones, it's called Wilcoxon signed rank sum test. And lastly, if we have three or more populations, and we have ANOVA to test it, and for non-para, we have Kruskal-Wallis. Okay, so all of those are three different kinds of, for three different purposes of statistical inference, and those are the parametric and its corresponding non-parametric approach. So when the normal assumption has been met, we prefer the parametric approach. If the normal assumption is not met, we use the non-parametric approach. Okay, so this is a non-parametric test. And someone says regression. Oh, come on, regression is a big topic. You can revise on the tutorial slides 10, I guess. You have 5 steps. Tukey's HSD test. So for Tukey's HSD test, it's multiple comparison, and you are not required to do any manual calculations. Okay. Tukey's HSD test. Yes, you don't need any calculation on that. You simply need to know if yi minus yj is greater than w, then we think the population mu I will not equal mu j. If it is less than w, then mu I equal mu j, right? So it's all about how do you perform draw your conclusion. So don't worry. So how to calculate p-value for a two-tailed test manually? You mean not using Excel, right? It's impossible to calculate p-value, okay? The key things, impossible to calculate p-value without Excel, okay? Impossible to calculate p-value without Excel for t-distribution, okay? For t-distribution or f-distribution, okay? Impossible. But sometimes they give you, for example, the one-tailed p-value, okay? The one-tailed p-value of a test is 0.03, and then the two-tailed p-value, what is the two-tailed p-value? It's 2 times the one-tailed p-value, right? 2 times 0.03, okay? So that's all. I believe that's the hardest thing you can be tested in your exam about calculating p-value, because we can never calculate p-value without using Excel. Logistic example, yes, we do. Can you please just do everything? Okay, come on, everything. I only have 41% of battery. Let's see, how much do I left? Yeah. Come on, how much do I left? Oh, shit. Oh, gosh. Oh, I still have 25%. Is everybody still here? Yes, I think so. Okay. Now, Wilcoxon ransom test. Okay. well, if you do want to know the Wilcoxon ransom test, can you read the assignment feedback? Is that okay? Because it's just on Canvas, and I have detailed Excel solutions on that. So it's just using the formula from your lecture slides, okay? If you still don't get it, just read it twice, okay? Could you please represent the process of stepwise regression? Well, come on. The process of stepwise regression. Come on, it's impossible to do a stepwise regression manually, okay? Impossible. So I don't think you'll be tested on the stepwise regression. So you only need to know stepwise regression is an approach to get the best model, okay? Now let's look at Nina Ni's question. Nina Ni's question say, hi Tony, I have some questions, hope you can answer. First, what's the difference between residual, standardized residual, and error? And is residual the difference between observed and predicted value? Okay, that is a very good question. Now, let's look at this. So, in our multiple linear regression model, it's usually yi equal beta 0 plus beta 1 x1 blah, 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 plus beta k xk plus epsilon, right? Epsilon I, for example. So this epsilon I is called an error term in this model, okay? Error term. So this is error, okay? So what does that mean? Let's see. This multiple linear regression model can be regarded into two parts. The first part is a straight line, right? So without the error term, it's simply a straight line. We can call this a population regression line, right? And the value of it is actually the expected value of yi given any x, okay? So expected value, because when you take expectation here, the error term has a mean of 0, so you can see it's just this straight line, okay? So every number on this straight line, I mean y value on the straight line is this expected, conditional expectation of y, okay? Now, where am I? Okay, now, when we have error term, the real data will become something like this, right? So this is the data with the error term. So the error term is actually represent the actual y value minus the expected y value, right? Because this point is the actual y value, right, after plus epsilon. And the difference between this is the observed value of the error term, right? So the error term is actually your actual data. This is our observed y, and this is the population regression line y, right, or the expected y. Now, what is residual? So what we're gonna do in a residual in a linear regression is that we will never know the true position of this population regression line, right? We know it must be somewhere over here, right? So for example, this is the true population regression line. But usually what we do is that we will take a sample. We will take a sample of the population and try to calculate an estimated regression line using this particular sample, right? So our line can be different from the population line, right? It's pretty much like the sample mean will be different from population mean, right? So the sample line, so they can be called a sample regression line or the estimated regression equation, right? Estimated regression equation. So when we talk about estimated regression equation, it's pretty much like an estimation of the population regression line, okay? So this is sample line, and this is this is the blue one is the population line. So we know that it will never equal to the population line, right? So in this way, if we still want to observe some error term, the error that we observe, it's not the true value of the error term, but instead it's called a residual, right? Because we will never know the true location of this blue line, the true population line, but we only know the estimated regression equation, which is given by y hat. So the y value on this line is y hat, right? So y hat equal beta 0 plus beta 1 x1 blah 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 plus beta k x k. Sorry, with all hats over here. Oh, 20% battery remaining. Great. All right. So EI is, oh, what's wrong? EI is y, it's actually calculated by yi minus yi hat, okay? So it's instead of using yi minus the true value of the regression line, or which is yi given x, but we will never know this value. So instead, we can only use the yi hat, okay? So this is, again, observed y, and this is the predicted y. Therefore, the residual is calculated by what? By what is that? By the observed y minus the predicted y, okay? Now, for standardized residual, again, the residual have its own variance, right? So if we divide the residual by its standard error of any residual, we will get what we call a standardized residual. Standardized residual. And this standardized residual usually follows a normal distribution with 0 mean and 1 variance. Therefore, we can use standardized residual to see if any point is an outlier, okay? So we usually believe that if a standardized residual is greater than 2, I mean the absolute value is greater than 2 or greater than 3, it's an outlier, okay? So this is the difference between a error term, a residual, and a standardized residual, okay? So standardized residual is nothing but standardize this residual because to make the variance of this residual to be 1, because the variance of residual it's usually the sigma epsilon hat, right? Sigma epsilon hat. So we want to make it 0. So we divide this by its standard error, and we can get the standardized residual. Okay. So this is the difference between error residual and standardized residual. Okay, Felicity Tang, how to interpret the coefficient in logistic regression. Okay, I just said that, right? Me too, you're not the only one. Terrible internet, okay? Do we need to calculate SSE, SSR? You'll be given ANOVA table. I think very likely you will be given ANOVA table because if you want to calculate SSE or SSR, you need to have the source data, right? So don't worry, you'll be given table. 41% electricity. Please speak English. I don't understand Mandarin. Okay, Team Chen will be required to write Excel function. I'm not sure, but it won't hurt. I mean, in your well, from my experience from previous semesters, there are questions like, please write down the Excel function of something, okay, from previous semesters. But I'm not quite sure about this semester, okay, because I never seen the exam question. Xin Wei Ying, just refresh it, guys. Yes. How to calculate the ranks in non-parametric statistics. Okay, for the ranks, you just rank the number. For example, you have a number of 6, 5, 8, 2, 4, 4, 7, 1. Okay, you have this set of data. So if you want to rank it, you first write it from the smallest to the largest. So it's 1, 2, no 3, 4, 4, 5, 6, 7, 8, right? So this is you order this data from the smallest to the largest, and then the rank of 1, we ranked it from the smallest to the largest. So this is the first rank, second rank, and when they have an equal number, we have an average of those ranks. So this one's supposed to be 3, this one's supposed to be 4. So we have an average. We have 3.5 on each. Okay, so this ranks 3.5, 3 times 5, and this is ranks 5, 6, 7, 8. Okay, so this is how we rank the data in non-parametric test. Okay, again, if you have two populations or two samples, the first sample is 6582 and 4471, you just rank them all together, okay? Put them all together and get the rank of each of them. And then you can have a rank sum of the first one and a rank sum of the second one and do your own calculations, okay? Adi asking, will there be table given critical value since it's not Excel exam? I think you will be given critical value. And I think the table, it's just a critical value table, right? Again, many of you are just curious about how the table works or complain about using statistical table. But I think it's much easier than Excel because in previous semesters, students prefer to use table instead of Excel because in Excel you have to input many things. But for table, you can directly, for example, if you look at the t-table, all you need to do is to find the degree freedom, right? And then what is the alpha, 0.05 or 0.025, and then you can just find that value, that corresponding value in the table. So nothing is easier than this, okay? So don't be panicked. Table, it's just another Excel. It's just an old version of Excel, and it's very straightforward. Just find out what you need, okay? Xinjia Bai is asking the number of degree freedom for the denominator of one-way ANOVA test for 5 population means with 15 observations sampled from each population is what? What? With 15 observations. 5. Okay. I think you are curious about the different degree freedoms in our overall F test and ANOVA, one-way ANOVA test. So that's pretty normal. So in a one-way ANOVA model, we define K to be the number of treatments, right? And as we see, the one-way ANOVA model is given yi equal mu I plus epsilon I, right? So if you want to estimate this model, you need to estimate K different population means, right? Because K is the number of treatments, you need to know mu1, you need to estimate mu1, estimate mu2 to estimate mu K, right? So there are K estimations in total when you want to estimate a one-way ANOVA model, right? So the SSR's degree freedom will thus becomes K minus 1, okay? It's the number of treatments minus 1. And SSE is N minus K, okay? N minus K. And for SST, it's N minus 1. So you can see K minus 1 plus N minus K equal N minus 1. So this is in one-way ANOVA model, okay? The degree freedoms are like this. But for our overall F test, you can see the K now stands for what? The number of independent variables. So if we want to do a model estimation from beta 0 plus beta 1 x1 plus beta k xk plus epsilon, how many parameters do we need to estimate? We do have beta 1, 2, 3, 4 to beta k. So those are k unknowns or k parameters that we need to estimate. But don't forget, we have a beta 0 over here, right? Beta 0 is also one thing that we need to estimate, right? So actually, in total, for multiple linear regression model, we have k plus 1 parameters to estimate, right? And for one-way ANOVA model, we have k parameters to estimate. Therefore, when we look at SSR, SSE, SST, the SSR's degree freedom should be the number of parameters to estimate minus 1. It's k plus 1 minus 1, so it's k, okay? So for SSE, it's n minus k is the number of parameters to estimate, right? But now it becomes k plus 1, so it's k minus n minus k minus 1. And for SST, again, n minus 1. So I hope this will help you, okay? So for your particular question, if the one-way ANOVA test for 5 population, so which means 5 treatments. So 5 treatments, SSR has a degree freedom of 4, and you have 15 observations sample from each population. So in total, you have 75. So this total one is 75 minus 1, 74. And 74 minus 4 is 70, okay? It's 70 minus k. K is 5, right? Okay, so hopefully this will answer your question, okay? Now, Jay say, look, how to interpret beta in logistic regression. Okay, we already say that. Refresh, work for me, working, yes. Refresh, please, streaming, fine. Winnie Xu is asking, hi, Tony, could I have the example of mutually exclusive and exhaustive events for stepwise model? How to determine which variable is important? Oh, yeah, this is 2 questions, right? Okay, so could I have an example of mutually exclusive? Well, I think I've got a cable delivered. Wow, that is awesome. Let me take it. And try to get my phone charged. Let me see, is it charging, okay? Oh, I'll trust this computer. Oh gosh, it is charging. It is actually charging, guys. This is fabulous. Okay, I'll go back. Look at here. You know where is here? Ah, this is our ABS. Beautiful ABS. Good. All right, now let's continue answering your questions. Mutually exclusive and exhaustive events, no problem. So if I have, for example, I'm rolling a die, okay? I'm rolling a die, right? So this is a die. And the possible outcomes are 1, 2, 3, 4, 5, 6. So I can define event 1 to be rolling a die and get 1 and 2. This is E1, right? And another event is to get a 3, 4, 5, 6, E2. So here, E1 and E2 are mutually exclusive and exhaustive, right? Because by mutually exclusive, they can never they can never happen together, right? Have nothing in common. And exhaustive means if we put them all together, it is the whole sample space, right? So in here, we say E1 and E2 are 2 mutually exclusive and exhaustive events. And for stepwise model, how to determine which variable is important? Well, stepwise is not a model. It's Stepwise is a process to determine the best model, okay? And there is no one rule to determine which variable is important or not. So we usually look at the p-value for the independent, p-value for the significance, individual significance, right? So if p-value is small, we think it's important, right? And if p-value is large, it's not important, okay? So we look at the p-value of the individual significance test, t-test, individual significance t-test. All right. And Yuan Liu is asking if residual plots exhibit heteroscedasticity, a good spelling. How can we decide which transformation we use? Well, you have to try, right? So sometimes you can take a log, you can take a square root, you can take whatever, okay? But there's no right or wrong answer. You have to try it by yourself, okay? Yong Xu is asking, can you please give us an example? An example of what? Sorry, I can't see your real life question, okay? So if you want to ask, can you please give us an example of something, okay? Can we see this after the live broadcast? Yes, you can. You can see the recording forever. You can even see my consultation from last semester, and I think it will help you a lot. Hi, Tony, could you instruct on how to look up the table? Well, for table, yeah, as I said, you just look at it, right? If you want, for example, if you want t half an alpha, t 0.025 with degree freedom 36, for example, you just look at, sometimes if, I don't think there's 36, but they have 30, 35, and 40, right? So if you've got a 36, as a degree freedom, you can simply use the 35 one, okay? And for example, if you got a degree freedom of 88, okay, but you only end up with the 80 and the 90, so you can you'd better use 80 to be conservative, okay, but not 90. So always round down your degree freedom in a t statistic, okay? And for normal table, well, nothing to say, right? Normal table, it's you just look at the probability, right? And you can find the critical value, okay? So I think if you really understand what is critical value and what is significance level, and then there's no problem for you to do a table, because I think it's much easier and more straightforward than Excel. Excel, it's a function, right? But for table, they give you chart, right? It tells you the probability to the left-hand side, right? And it's what, and then they will give you this value. So it's very straightforward. It's pretty much like our distribution tool you use in Aprilia, okay? MP is asking, estimating two normal population means there are two formulas for equal variance and unequal variance. Does variance in this context refers to sigma or variance in observation in the two populations? What do you mean by that? What? Observations in the two populations, they are the same thing, right? Refer to sigma. Well, we assume two populations have the same variance, which means sigma 1 square equals sigma 2 square, right? But we test this using sample variance, because we will never know the value of the population variance, right? So we will see whether S1 square is roughly equal as 2 square by constructing a F statistic, right? So if this is one, it's too large or too small, then we think they are not equal. And if it is not too large or not too small, I think they are equal. So the population variances are equal. Okay. Okay. Johnny Duan. Well, I love this teacher. Yeah, thank you very much. Christine Shi. Hi, Tony. The question is, calculate the value in a chi-squared distribution with full degree of freedom such that the area to its right is 0.99. So what is that? Where did you find that question? Yes, thank you, Mark Xie. Thank you. Okay, the odds. What? Sad. What is that? 7.329. Okay, anyway, thank you. Thank you. We have the calculator. Thank you. Give me a rocket. Okay, 0.88. Okay, anyway. Oh, where am I? Oh, I lost. I got lost. You asked so many questions. Oh gosh. Oh, I'm back. When this will end? I don't know. When I've finished answering all your questions, right? But how can we judge whether it is successful? Okay, Nina Ni. Successful. What is successful? Probably you are referring to successful. Oh shit, where we are. I think you are talking about the logistic regression, right? So if it is logistic regression, and you make an estimation, for example, if you have a probability of recommending this course to others is 90%, then it's more likely than less likely to recommend this to another student, right? But if it is 40%, namely less than 50%, then it will not, or more likely not to recommend this course to others, right? Okay. Before Victoria Jiang is asking, before conducting Spearman z-test, do we need to state central linear theorem first? What if the sample size is smaller than 30? Okay, I don't think the exam question will be that vague, okay? You know what I mean? It will directly tell you what to do, okay? So if they tell you do a Spearman z-test, then they will tell you do a non-parametric test, okay? Or if the population does not follow normal distribution, all right? Chloris Hu, what is the conclusion on this result? What is this result? Can you specify which topic? Because I'm still looking at very old chats, okay? Chloris Hu. So hopefully you can find us. Heather Hu, how to do Wilcoxon match pairs signed rank test? That's a good question. I don't think it will be tested. Don't worry, don't bother. Because I saw different versions. Can you see that? Different versions on the match pairs. So in your slides and in the formula sheet, there are different formulas, right? So you'll see. This means they never use the question to test if the formula is right or wrong. So that means no question about the match pairs, okay, on non-parametric test. What else? Someone asking, is the chi-square test always one-tailed? No, not really. Sometimes it's two-tailed, sometimes it's one-tailed. It can be one-tailed, two-tails. So it depends on whether or not it is, whether or not it's one-tail or two-tail, right? But you don't need to worry because final exam is a closed book. Closed book means we will test on your very basic things, okay, or basic understandings. For your assignments, because it's an open book. So for open books, there have to be some challenging questions. Otherwise, everybody is able to solve every single problem, right? So I believe final exam will not be more tricky or trickier than your mid-semester. So don't worry. An example of ANOVA. Example of ANOVA. You can actually I think you can go back to our tutorial. Which tutorial? Tutorial 9. It's tutorial 9 ANOVA. So tutorial 9, or go back to the lecture slides. And ANOVA is used to test. I think we there are two times or two occasions that we need to use ANOVA, right? One is to test more than two population means, right? So this is when we use ANOVA. And another circumstance of using ANOVA is the overall significance F-test, right? In our linear regression, okay? So test 2 plus population means or overall significance F-test. So you need to know this one is testing whether mu1 equal mu2 equal mu k. And this one is at least one pair of the mu I not equal mu k. And for overall significance F-test, the null hypothesis is the beta 1 equal beta 2 equal beta k equal 0, and at least one of them is not 0, okay? So there are two occasions that we apply ANOVA, okay? Assignment was horrible, so it's a nightmare. Yes, I agree. Okay, good. Yep, exciting. What makes you so excited? No non-parametric question exam. I think the hardest. Well, I can't say anything, right? But from my experience from previous semesters. So from previous semesters, for non-parametric tests, they usually just ask you to do some simple calculations. Like you need to be able to know how to rank each data, right? And you need to get the rank sum of each group of data, all right? So that's yeah, I think that's all. Or they probably ask you to calculate something, like calculate z. So z is simply the rank sum minus ET divided by the standard deviation of t. And I think this is going to be the hardest question you can have, okay, for Wilcoxon rank sum test. So just go back and see our assignment feedback, okay? Awesome, thanks, Tony. Do we have to calculate SXX, XY in the final exam? Again, for the SXX and SXY, you only need to know what they are, okay? But you probably not be asked to calculate it because you don't have Excel, right? So you need to think about this. Even though I admit sometimes Artem can make your life very hard, but he's still a human, right? And he's actually very good. So he will not, put a hard time on you if, for example, if you only have calculator and then he give you 100 data and please calculate SXX, right? So only need to understand SXX is the sum of square of all the data of X, right? And that's enough. Topia Mikrias, it says there are non-para formula in our formula sheet. Yes. Rank +1. Maybe tested. Yes. Rank. Easy to calculate. An example of ANOVA. Oh, why you ask an example of ANOVA again? Johnny Duan is asking, will this be recorded, Tony? Yes, it will. So you can watch it repeatedly. For Wilcoxon, if it's a right tail test, we use the larger than sum ranks for the test statistic. Well, if a right tail test, for example, in Wilcoxon, we are asking whether group A is greater than group B's location, right? Because in Wilcoxon ransom type, we always use location. So you probably have TA and TB. If it is a right tail test, well, actually the right and left, it's all about you put whom to the first, right? So if it is, if you don't want to say if this one is greater than this one, then you use TA, right? Because in this way, TA, you are expecting TA greater than TB, right? So you just want to see whether TA is significantly larger than TB. And again, if it is a what somehow left tail test, again, you're going to look at if TB is significantly greater than TA, right? Because a higher value will have a higher rank. Is that right? So same thing. So instead of comparing sample mean, we are actually comparing the rank of each data to determine which one has a higher location or to the right location, or whether the location are the same or not, okay? In Wilcoxon, MP is asking, in Wilcoxon run some test, always a one-tail test because it's based on location. Well, it can be a two-tail test, right? Yeah, it can be, because if we want to know whether the location is different, then either TA greater than TB or TA less than TB can help us reject the null hypothesis of the same location, right? So if TA is similar to TB, then we do not reject null hypothesis. So we just compared whether TA with ET and TB, whether they are far away from each other, right? Chi-square to see if two sets will have the same location or not. One tail, two tail should depend on alternative. Yes. Will this be recorded, Tony? Yes, it will. An example of ANOVA, please. What example of ANOVA? Well, example ANOVA, go to the tutorial question probably. Yeah, just go to the tutorial question. Is the chi-square test always one-tailed? No, not always. It looks like I'm repeating the questions. Ryan Zhao is asking how to precisely calculate the confidence interval in regression model. Could you please use the tutorial example? The father age and son age, how to identify the standard deviation SSX. Yes, that's true. So that's why you will not be tested, right? Ryan Zhao. Because it's really hard. I mean, the confidence interval is constructed by yi hat plus or minus, what is it? Some t, right? T half an alpha n minus 2 multiplied by an error estimation in square root of 1 over n plus x minus x bar. Do they have a square or not? I don't know. And divided by SSX. So can you imagine if you're asked to calculate this kind of thing in your exam? You're going to be crazy, right? So I don't think it's likely to happen. So for even if you are asked this question in your exam, you will definitely be given what is SXX, okay? Because I don't think you'll be asked to calculate SSX. SXX is x minus x bar squared. So you need to observe every single x in the data set in order to calculate SSX, okay? How do we get a p-value from f-test manually? Again, as I said, we cannot do that without using Excel, okay? But you need to understand. You need to understand in f-test, the p-value is the probability to the right of your observed f, okay? You need to understand this, but it's impossible to calculate, okay? How about t-critical value? Well, for t-critical value, we can find it out in a statistical table, right? So, for example, t-critical value, if we want to know t 0.025, and with a degree freedom, I think I answered this question just now. Okay, so, yeah. Xinwei Zhang, if the question asks, okay, please, come on. Yes. Yes. Why you say yes? Anyway, what is the meaning of Excel command in the formula sheet? They are Excel commands, right? Yeah, the meaning of Excel commands are the Excel commands that you can use using Excel to find out either probability or critical values, okay? So let me guess. For example, sometimes they probably ask you what is the Excel command of getting some critical value, right? So you need to be able to write t dot inverse something something something, and I think you are given in the question in the formula sheet of all of the Excel functions. So it's even easier than your mid-semester exam, right? In your mid-semester, you are not given any Excel functions, or do you have any? Probably you do, but yeah, but again, write it down, right? Yes, we are here. Yes, we are here. Xu Jiaxi is asking, since there are not equation about SSS, so this means we don't need to calculate this in exam. I think there are formulas, but I think it's insane. Again, as I said, calculation is not that important, and it's not something that we are going to be looking at because we want to see your understanding, okay? So for SXX, for example, it's simply observe x minus x bar and sum of square. It's a sum of square. And x and y is x minus x bar times y minus y bar. So it's their co-variation, right? But not covariance, because covariance is actually divided by n minus 1. So this one divided by n minus 1 is what? The sample mean, sample variance, right? So it's SS squared. And this one divided by n minus 1 is the covariance of SXY, right? So you will probably not be asked to give you a data, right? You have X, 3, 4, 5, 6, 1, 2, 5, something like that. And then you ask, what is SXX? This is stupid, right? This is not a mathematics exam, right? Or primary school mathematics exam. So you probably not be asked to calculate this kind of tedious things, but you have to know what is SXS, okay? How many F tests did we learn this semester? Can you please summarize? Okay, Yongxu, that's a pretty good question. I think actually this is something that you need to do it by yourself because you are learning for yourselves, right? But if you ask me to do that for you, I'll have a try, okay? So the first F test we learned is the two population variance, right? Two population variance. So the null hypothesis is the variance 1 equal variance 2, and the alternative is variance 1 not equal variance 2 or greater or less than, right? And the F is constructed by the S1 square over S2 square. So this is one test. And we reject the null hypothesis if F is too large or too small, or the p-value is less than alpha. And the second F we learned is the ANOVA, one-way ANOVA F test, right? One-way ANOVA F test. And the null hypothesis is all the population means are equal, right, to mu k. And alternative hypothesis is at least one mu I not equal mu j, right? At least one pair. And we construct F using MSR over MSE, and we reject the null hypothesis if F is too large. So it's one-tailed, right? This is a one-tailed, and or the p-value is less than alpha. So this is second thing. And the third F test we learned is the overall significance F test, right? Overall significance F test. So again, the null hypothesis is all the coefficients other than beta 0, beta k equals 0, and alternative is at least one beta I is not 0, right? And F is again constructed by MSR over MSE, and same thing, one-tail test. We reject the null hypothesis if when the observed F is greater than critical value, which is when F is large, or the p-value less than alpha, right? And the last F test we learned is the partial F test. So the null hypothesis is when we cut down some independent variables from the full model, we want to see the independent variables we cut down are equal zero or not, right? I mean, the coefficients of those independent variable equal 0 or not. So we can say all the beta cuts, right? So beta cuts, I can say beta cuts, but if it is asked in your exam, you need to say, for example, you cut x1, x3, and x2 from the model, okay? You remove this from the model, so you need to text whether beta 1 and beta 3 and beta 4 jointly equal 0, and whether if at least one of those betas are not equal 0, right? And this F statistic is constructed by the SSR of the full model minus SSR of the reduced model or restriction model. And the problem is in your assignments, I saw a lot of students using SSRR minus SSRF and get a negative value F, and they still put it there, right? Have you seen any F value to be less than 0? So if you really understand F distribution, it must be something like this, right? It will never get a negative value. It's always positive. So if you calculate F that is less than 0, you need to think about there must be something wrong, right? So the full model SSR minus reduced model SSR divided by, for example, this is 3, right? So for example, in your full model, you have k independent variables, and now you cut down 3. So k minus, it's just 3, okay? The number that you cut down, okay? So in the formula, it's k minus p. K is the number of independent variable in your full model, and p is the number of independent variable in your reduced model, okay? And then divided by the full model's SSE over n minus k minus 1, okay? So this is how we construct F. Again, reject the null hypothesis if the observed value of F is greater than the critical value of F, or the p-value is less than alpha. Again, you are not able to calculate the p-value over here, so you can only do F observed if F observed greater than F critical, if you do it manually. Okay. Will we require to calculate coefficient of the regression model? Chan Nathan, thank you for your question. I don't think so. I mean, again, even though you are not required to calculate it manually, but you need to understand. Well, for multiple, definitely not, because we haven't learned the formula, right? But for simple linear regression, we did learn beta 1 hat equals the covariance, or the SXY divided by SXS, I guess. Yes. And you're not required to calculate this. You're not required to calculate this, I guess. But there is possibility that you are given SXY and SXX, right? And you calculate the coefficient, right? And the beta 0 hat is simply, we know y bar is always in the model, so y bar minus beta 1 hat x bar. So you know x bar, y bar, but it's very likely that this will not happen in your exam, because from history, we don't test on this kind of stuff. We only care about how you understand the outputs, but not how you calculate something, okay? It's more about understanding. Why formula sheet has Excel formula? No, why? We just want to help you, right? So if you use Excel, if only you are asked, because I think the reason is that in previous exams, previous semesters, we do have questions like, please write down the Excel function of what, okay? And then they give you Excel formula. So this formula sheet is just copied from previous semesters, I guess. It remains the same for several years, so don't worry. Excel help, well, it's there better than nothing, right? So what if there's no Excel formula, and in the question they ask you, write down the Excel function of something? What's going to happen, right? So it's a good thing if you have Excel formula, right? So Teddy Yu, when will the final exam start? 9:20 or 9? I really double checked with Autumn, and let me read what Autumn wrote to me, okay? and I still got a little bit confused. Let me check exam time. Okay, Autumn said, "Hi, Tony. The exam is administered by exam office as per timetable." Okay, so this means for timetable, look at the exam office, right? And he also said, "Coming earlier does not hurt." Okay, this means if you come by 9 a.m., it does not hurt, okay? But I think 20 minutes more sleep really matters, right? So I think it's safe if you come by 9:20, okay? Let's see, 2.5 hours duration. So the exam will be 2.5 hours plus 10 minutes of reading time. Okay, so this is how Autumn replied me. So from the words timetable follow exam office, 9 a.m. does not hurt. Does it mean that it actually starts from 9:20 a.m.? But he is very nice because he just don't want you guys to be late to the exam. So he announced 9 a.m. That's my guess, okay? What do you think? If that's 天虚, so what will be tested manually? What do you mean by that? Everything is tested manually, right? Nina Ni, hi Tony, what are the assumptions of simple linear regression model? Same as multiple linear regression model. Same as a ANOVA model, right? It's just in your lecture slides. Read them. Farah-Ism, can we calculate the coefficient of MLR model manually? No, we can't. I mean, it's impossible. It's totally impossible. Will the Spearman rank coefficient be tested? I don't know. I mean, everything is possible, right? MP is asking, in the test book, it asks to perform ANOVA given n sum of x and sum of x squared. How can variance be calculated from this? You are asking that a PLIA question, right? I think I did perform that question, that calculation in the mid-semester consultation video. So if you can go back to the mid-semester exam consultation video, you will see that, okay? No Spearman in final, I asked lecturer. Wow, really? Great. Xiaodong Liang, what's the difference between EY and Y hat? And they are just different notation for same meaning? No way, guys. Xiaodong Liang, EY is the population expectation, okay? So it's the population straight line. And Y hat is the sample straight line. They are never the same, okay? So on the red line, it's Y hat. And on the blue line, this is the true population thing. It's EY, okay? It's pretty much like mu is population mean and X bar is sample mean, okay? So Y hat is sample line and EY is population line, okay? Is that clear to you? Yes, Xin Wei Ying. Yes, thank you, Xin Wei Ying. You answered the question right after that. Yeah, it's true value. Y hat is the number we get from the best estimate regression. Yes! Okay, Little Chen Yu is asking, textbook have formula to help us to calculate SSA. Yes, we do. But we won't be testing SSA, probably, yeah, no. And Xiang Jin, could you please talk a bit about residual plot, how to identify the mean of the error variable equals 0, or the distribution of error variable is normal from a residual Y hat plot? Well, so first of all, for residual plot, we can never see if it follows normal distribution, okay? Because residual plot, it's just residual plot, right? We cannot see if it follows a normal distribution. So this is first thing. So the only thing we can look at from a residual plot are two things. The first one, whether or not the error term and any independent variable has no correlation. Okay, so they need to have no correlation. And the second one is whether the variance is constant, right? Or the heteroscedasticity or homoscedasticity. So let's look at the first one. If the error term and the independent variable is not independent, we usually observe some patterns between the residuals and the x or y hats. Okay. So you can plot residual against y, every single y or every single x and y hat. And if you observe something like this, it means this EI has some relationship with x, right? So that's why you can see there is relationship. And for the second one, variance constant, this is pretty simple. If the variance is not constant, right? If the variance is growing up, then it violates this assumption, right? So only those two things can be identified from a residual plot. Is that okay? And we cannot tell whether the data follows normal distribution from the residual plot. JZ, calculate them. Yeah, really no SS set by Co. Really no SS and no Y set by lecturer Andrew. Yes, EY and Y hat are totally different things. Yeah. Good. That's a wonderful presentation. Thanks. Oh, is this stuck? Oh no. What is the meaning of Excel command? Why are you asking the same question again and again? The meaning of Excel command is it's Excel command, right? Do we need to calculate SS and unit? No, I don't think so. Are we required to read the Z table or T table? I think so. Will we be testing about SX7? Well, everything is possible. I don't think you'll be asked to calculate those things, right? But you need to know what they are. Hi, Tony. I'm confused about the example in the logistic regression. Y long increase 2.7, R will increase 2.7. Okay. Well, I can tell you. So, if, for example, if x in the logistic regression, let's go back. I can illustrate y is percentage, okay? This has something to do with continuous compounding. But you are definitely not required to understand to this level. But if you're really curious about this, let me show you. So, we can see when x increased by 1%, increased by 1, when x increased by 1 mark, the log of r hat becomes 0.0277 more, right? This means the log of r hat new, this is the new thing, okay? And minus the log r hat old equals 0.0277. Is that right? So this is 2r hat. So when x1 increased by 1, log of r hat will increase by 0.0277. Is that right? So we know that this means the log of r hat, well, this is r hat dash over here. R hat dash divided by the r hat equals 0.0277. So this is the law of logistic, right? And we know that r hat dash divided by r hat will be e to the power of 0.0277. So this means what? This means from r hat to r hat dash, it will increase by this proportion, right? And you can calculate this. This one is roughly equal 1 plus 0.0277, okay? Roughly equal to 1 plus 0.0277. That's why we say the r hat will increase by 2.77%, okay? So this is continuous compounding in finance, okay? Yeah, hopefully this answers your question. Chenny Wu is asking, when we rank, I remember we need to use the median. It's the same as the average. It's just the average. Yes. I think yes, you use average, right? Yeah, you use average. For the rank, the median and the average are the same thing, right? So for example, if the 3, 4, 5's average is always 4, right? And the average is also 4, median is 4. And if it is 3, 4, the median is 3.5, and the average is also 3.5. So yes, same thing. Oh, let me drink some water, okay? Aha. In Spearman correlation test, do we have to know how to calculate the R's? I think from your lecture, Andrew, the Spearman correlation will not be tested, right? So don't bother. What's the meaning of the first row of Z table? The first row of Z table. What's the first row of Z table? I think I need to get a Z table. Let me Google a Z table and see. What do you mean by first row of Z table? Ah, I see. Okay. For Z table, the first row gives you the precision. So for the first column is minus 3.5, minus 3.4, and the first row gives you 0.01, 0.02, 0.03. This means 3.51, okay, minus 3.52. So this one is when the probability to the left of minus 3.51, okay? And this is 3.52, this is 3.53, and 0.04 is 3.54. So if you have 2.6, if you want to have calculate the probability of minus 2.65, okay? So here is 2.5. Oh, I think it starts from 0, right? And then 1, 0.02, and 3, 4, 5. So you'll be looking at this row in this column. So you look at this number, and this will give you the probability to the left-hand side of minus 2.65, okay? So this is how you check the normal probability table. Can you find a tutorial by Google Pro Yicheng Pan? You can find a tutorial by Google Yicheng Pan. What is Yicheng Pan? Do we need to calculate in the exam manually? Again, no. It would be nice if you could speak Chinese. Sorry, I can't. Hi, Tony. I would like to know when to use T1 and T2 in 2 Wilcoxon tests. It's up to you. You arbitrarily choose T1 or T2 as T, okay? Because it works like this. So we have two set of data, right? And we have the rank of A and rank of B. And there is also an average rank, the ET. So ET will be a number in between TA and TB, okay? So the only thing we'll be looking at is that whether TA is far away from ET or TB is far away from ET, right? So you can choose either ETA or TB. It doesn't really matter at all, okay? So that's why you say T can either equal EA or T equal TB, because all you need to be looking at is to see whether T is very far away from ET after some standardized adjustments, okay? So you want to see whether T is far away from ET. So if far away from ET, it means T and TB are significantly different, right? And I believe TA and TB have the same distance from ET. Oh, why is it offline? Okay, I think this time it works. Okay, so ET and you see. Could you please review the F-test, which is statistical inference for two population variances? So I just do that. I don't know whether you asked this question before I explain F or after, but it doesn't matter. You can read the slides really, and again, well, the F for two sample variances, null hypothesis is sigma 1 square equal to sigma 2 square. Alternative is sigma 1 square not equal to sigma 2 square, right? And F is constructed with S1 square, S2 square. And we reject null hypothesis when F is greater than F critical, the right tail critical, or F less than the left tail critical. Okay, this is critical right, this is critical left. Or, but more importantly, we can look at p-value, whether p-value less than alpha, because F is not symmetric, right? So F is something like this, and the middle somewhere is 1. So we want to look at whether this proportion is significantly larger than 1. So this is F right, and we also have a F left. So this is left value of F. So yeah, and the p-value is the probability of those two guys add together. All right, so this is variance, two population variances. Okay, Huang Zhang is asking how to determine which one is a Pearson or Spearman. See whether population is normal, right? Oh, it's stuck again. Oh gosh. Does it stuck? Let me refresh it. Oh, I lost many of your chat. Oh my God. I can only start from Kathy Chan. So Kathy Chan is asking, could you please explain that round down? Why choose 80? To be conservative. Conservative, okay? To be conservative, we always round down. But it doesn't matter. I mean, you will always be correct because you haven't learned this, right? So when we do the marking, you're always correct, okay? Don't worry. So Jin Wu is asking, will Coxon sign rank some tests? We get T minus and T plus. Which one should choose smaller one with absolute value? Don't bother because different, your slides and formula sheet gives different results. So just ignore it, okay? How to explain the coefficient in the logistic regression? I've done that. Because you need to be conservative. Yes, you need to be conservative with degree freedom. Open book, but no time. Open my book. Yes. When will release the assignment grades? I'm still marking it, right? So if I don't do the live streaming now, I can mark 20 or 30 more of your assignments, right? But I still choose to do the revision because I think this is much more useful. And believe me, your assignments will be very good, okay? Don't worry. Ha ha ha. Open book but no time, open my book. Tutorial 9 is ANOVA, yes. Open book but no time. Cannot catch you. What do you mean by cannot catch you? There's a question in the book, use the regression equation to determine the predicted value of y. Predicted value of y, how to approach this. So MP, for your question, if you're asked to use the regression equation to determine the predicted y values of y, predicted value of y's, you are just asked to make a prediction. You will be given x1 equal what, x2 equal what, and plug in all the number in your estimated regression equation, you get a y hat, okay? So it's just simple calculations, don't worry. Use T plus compared to larger z-crit. Oh gosh, thanks for letting me know. Rolling Cheng, poor listening. Oh really? it's not your fault, it's me, poor oral English, right? Is the distribution probability on the table always one tail right? Well, gosh, what are you asking? Let me see what you're asking, okay? Is the distribution probability, I think you're talking about probability distribution on the table, always one tail? Ah, yes, on the table it's always left tail, right? It's just like our T inverse or normal inverse, sorry, T dist or normal dist, right? Double click 66. I wonder if Artem is watching this. I don't think Artem will ever watch this, don't worry. Double click 66, yes. Do we have to remember the PICI formula? Is that in your formula sheet? I think if that is not in your formula sheet, you won't be tested on that. Let's see. Let me look at your formula sheets. Formula sheet. Formula sheet. Formula sheet. Formula sheets with formulas before meet. Let's see. CIPI, CIPI, CI. Ah, there it is. So, yes, but I don't think you'll be asked to calculate that. But you need to know which one is wider and which one is narrower, right? For confidence interval and prediction interval. Okay. And human 666. Yeah. Hi, Tony. Can you talk about Spearman rank correlation coefficient when n greater than? Why can't I just use CLT to prove it's from normal distribution, but to use a non-parametric test? Yeah, that's a pretty good question. That's because the normal assumption the central limit theorem will only give us the sampling distribution of sample mean follows normal distribution, okay? It doesn't mean that n greater than 30 population is normal, okay? It means that when n greater than 30, the sampling distribution of sample mean follows normal. So it has nothing to do with correlation, right? So n greater than 30, x bar follows normal, okay? But it has nothing to do with the sample correlation R, okay? So again, you need to assume normal distribution, not normal. And one more thing is that if you want to X bar to follow a T distribution, which when we have sigma is unknown, the T distribution, even though n greater than 30, we usually also require the population to be normal, or at least not that non-normal, okay? So it can be wider, right? But not that non-normal, okay? So this is something from your textbook. So if you read your textbook carefully, you will see that, right? I read it like 3 years ago. I still remember this. This is very annoying because for sampling distribution T, of sample mean T, you have to assume population follows normal, or at least not that non-normal, even though n greater than 30. But I don't think you will be tested that closely in your exam, okay? Rolling Cheng is asking, choose TA or TB. It doesn't matter. They are always gives you the same result, okay? Chenny Wu is asking, when we calculate the Wilcoxon signed rank sum test, can we use T add or T minus arbitrarily? I don't know. I think there are some disagreements on your slides and your formula sheet, so I guess no. For chi-square test on residuals, chi-square, okay, now the random error normally distributed. Yes, random is not normally. Yes, distribute. Could please explain why is a one-tail density or two-tail test? Yeah. So for your question, it's pretty much like it's all about chi-square, but I don't think it will help your final exam. So chi-square distribution is something. Chi-square is the normal. It's different normal square add together is chi-square, okay? So why is it a one-tail test? they just use some distribution things in your underlying data and construct a chi-square test, a chi-square statistic. If it is larger than a particular value, you have to, for example, larger than 1, you have to reject the null hypothesis. When it is close to 1, it means it looks like several normal distributions add together, okay? But you don't require to know that, okay? For chi-square, yeah, Liao Luo, oh, I love you. Yes, I love you too. SQ Luo is saying, hi, Tony. If we want to do some practice, should we focus on the tutorial questions? I think, yes, you'd better look at the tutorial questions. And even though they are in Excel, but try to know how to understand each thing. So I think the best thing of doing revision on regression is to look at your assignment feedback, okay? Assignment feedback. So in the assignment feedback, and there is assignment question, we have regression questions, right? So I think that will help heaps, okay? That will help heaps. Overall, how many hypothesis tests do we need to know? Oh, come on. Gosh. How many hypothesis tests? You at least need to know all the tests in the regression, right? So in the regression, you need to know overall F, and you need to know the T, right? And you need to know the rows test, and what else? T-test for individual row, and any others. Probably partial F, but you've done that in assignment, so I don't know whether they test you again. But yeah, so this is all the tests probably you need to know in your regression. And also Dubin-Watson test for autocorrelation, and what else? Name it. You name it. So if you don't have time, just focus on those tests, okay? And if you got time, you can go back and look at the mu1, mu2 stuff, p1, p2 stuff, and something like that, okay? If you don't have time, focus on all the statistical tests in regression, okay? Sharon Nee, will you provide ZTF tables in the exam? I think so. But actually, to tell you the truth, I don't think there will be any questions about the table, okay? Oh gosh, nobody listen to this, right? I don't think there will be any questions using table, okay? Check announcement, they will. There will be tables in exam. Yes, thanks, nice, thanks. Hi, Tony. What is right-tailed Wilcoxon ransom test? Right-tailed is whether A's location is to the right, okay? Location is to the right. So in this way, you use TA minus ET, is that right? And then divided by the standard deviation of T, and to see whether this one is greater than 0.05 instead of 0.25, okay? So yeah, this is one-tailed Wilcoxon ransom test, right? Why Excel command? No why, right? Hi Tony, may I ask when will F-test be a two-tailed test? Variance, equality of variances is a two-tailed test. Adi, Tony, to ease some burden, is going through the tutorial exercise and lecture sample more than enough to enable us to tackle the exam? Again, nothing will be similar to any kind of exam questions. So all you need to do is to understand, okay? Understand, okay? It's all about understand. And if you don't have time, look at the assignment feedback, okay? Look at the assignment feedback, especially for the regression part, all right? Hi, Tony, could you explain the meaning of all different patterns of residual plots? Yeah, I think I've done that, right? Yes, residual plot, this one. The correlation, exists correlation between independent variable and error. And the second one, variances are not constant. Okay, so that's all possible patterns. Also, they can combine. For example, they combine this with an equal variance, right? So not only the values have relationship, but also the variances becomes larger when it's far away from this value, right? So it can be anything, but just look at whether there exists this kind of features, okay? Will we know the assignment score before the final? I don't think so. But you know what? A good thing of getting to know your assignment score after final is that once you, for example, you find yourself fail, right? Fail the unit. I don't think that will happen. But if you fail the unit, you can look not only your final exam, but also appeal on your assignment mark, right? So you can appeal too. But if the assignment comes too early, you will not be able to appeal on your assignment marks, right? Oh gosh, I'm so bad. Cut off this, okay? Hey, please cut off this part, all right? Jimmy Wong, hi Tony. For the one-way ANOVA assumption, errors independent normally distributed have constant variances, or data independent normally distributed have constant variance. Jimmy Wong, same. Why? Because the data is constructed by a mu I plus error, right? So if the errors are independent, then the data are independent, right? And if errors are normally distributed, then the data is normally distributed. And if the error have the constant variance, the data have the constant variance. Is that right? Could you please explain what is statistical inference and give us an example of question? Thank you. Oh, statistical inference is calculating confidence interval, right? That is inference. So for example, if I want to infer the population proportion, what do I use? I use sample proportion p hat, right? And the interval can be constructed by p hat plus or minus z half an alpha multiplied by square root of p hat times 1 minus p hat divided by n, right? So this is called inference, statistical inference. Ruofan Wang is asking, what's the meaning of 1 minus beta and 1 minus alpha in the decision rule? Oh my goodness. 1 minus beta. Beta is the power of the test, is the probability of having a type 2 error. So 1 minus beta is the probability of not having a type 2 error. And alpha is the probability of having a type 1 error. And 1 minus alpha is the probability of not having a type 1 error. Okay. Rohan Zhao is asking, is ANOVA y within bar, y bar, y? Oh my gosh, what is y within bar? What different from the regression model? Neither SSE calculation formula. I think they are the same. Same. Oh, y group mean. Oh, you mean group mean? Yeah, group mean. So well, let's do a quick thing. So y observed is the same in y observed. So this is ANOVA model. This is regression model. Okay, y observed is still y observed. In ANOVA model, the y group bar is y hat. Okay, it's more like y hat in regression. And the y bar, grand y bar, is again grand y bar over here. So you can see for ANOVA, you have a grand y bar, and you have y1 bar, y2 bar, and the y3 bar, right? And you have some observed data over here, and over there, right? But for regression, you also have a y bar And on this y bar, we know that x bar, y bar is always on the regression line. And this is y hat. So all the data on the line is y hat. So it's more like a continuous group, right? So this is discrete group 1, 2, 3. And for different y hat, they are group mean, infinite number of groups, right? And this is the data. This is the data in group 1, data in group 2, group 3, group 4, group 5, So for each group, they have a group mean. So this y hat is more like a group mean, right? And this is the actual observations. The observations. Okay, so this is probably the corresponding notations of in ANOVA and regression. Okay. Swatika Gupta is asking, what about the formula for the test statistic for Dubin-Watson test? So Dubin-Watson test, no need to know how to calculate. Even Atom don't know how to calculate it. You will only be given D, for example, 1.87, and you need to determine whether there exists autocorrelation. Super simple, isn't it? Okay. Adi Salman is asking, when will you release the assignment mark? When I finish marking, okay? MP is talking about, can you explain the difference between R square and multiple R? Okay, R square. R square, for example, if R square is 0.89, multiple R is R, it's 0.9. So it's the square root of R square. Oh, it's 10 p.m. already. Let me turn on the light. Okay. Oh, what's next? Could you explain Dubin-Watson test? Okay, again. So in your formula sheet, you will be given a D, 1.87, right? And you will also be given DU and DL. So we have 0, we have DL, DU, 2, 4 minus DU, and 4 minus DL, and 4, okay? So DU and DL will be given. They can be 1 point something, DL 1 point something, okay? So if you observe this D statistic is within this range, it means no autocorrelation, okay? If it's within this range, it's inconclusive, which means we cannot make any conclusion. If they are within this range, there exists autocorrelation, okay? Awesome. So this is Dubin-Watson test. Is there any special meaning of multiple R in MLR? The special meaning is the special meaning is adjusted. It's a coefficient. It's called a coefficient of determination adjusted for sample size and number of independent variables. So this is the meaning of multiple R. Oh, sorry, I thought you were talking about adjusted R square. So this is adjusted R square. And multiple R, the meaning is the correlation between Y and Y hat. So this is multiple R. The correlation between Y and Y hat is multiple R. So start at 9:20? Yes, there's only one truth. What do you mean by only one truth? Ha 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 ha. But I need 20 minutes of sleep. Oh, I know where you are. Cool, that's my true Atom style. Yes. Haha, do you have freestyle, Tony? Freestyle, yeah, I have a freestyle, great. Hi, Tony, sorry my previous question was not clear enough. I'm confused how we can justify assumptions. X is measured without error and regression coefficient independent of the random error. Okay, X is measured without error. We can't justify this, okay, so don't worry. We just measured that X without error, so we can't see it anywhere because if we measure it with error, we can't find it out, right? And the regression coefficients are independent of the random error. Coefficients are independent of the random error. Okay, so this means again, when we look at the residual plot, where's my residual plot? Oh, where's my residual plot? Oh, it's here. Yeah, this one means there is some correlation between independent variables and error terms, or coefficients and error terms. Okay, so same. So if we observe something like this, it will violate this assumption. Nina Ni is saying what I was thinking about assumptions for them all is MLR has one additional that is X uncorrelated. Yes, so it's multicollinearity then, right? Yes, can you talk about the beta formula, the hypothesis testing for regression coefficient? Thanks. The beta formula, the hypothesis testing for regression coefficient. Okay, what's wrong? I mean, all the test statistics are calculated by what? The point estimator minus your hypothesized value divided by the standard error, right? So again, the test statistic of beta is, the point estimator is beta hat, beta I hat, and the hypothesis value is your beta I, and then divide by standard error. So standard error is the standard error of beta I hat. So this one you can find in your Excel output. So the first column is coefficient, second column is standard error of each coefficient, right? So you can find the standard error of this beta, and this is the coefficient of the beta, and this beta I is in your null hypothesis. So if your null hypothesis, you assume beta I equal something, and then this is the something you need to plug in. So pay attention. In our previous test, we only talk about if beta I equals 0, right? So if beta I equals some other value, you still need to be able to perform this kind of test, right? But nothing, but just substitute, instead of 0 here, you substitute any beta here, and then calculate the t and see if t, if it is one tail, you to say t is t greater than critical value, or t less than t critical value if it is left tail, and or you look at p-value less than alpha or not. But you're probably not given alpha, you are not given p-value, so probably need to know critical value, I guess. Okay. I read assumptions. Oh, where is our chat? I read assumptions from Mela from textbook, did not find that in slides. Okay, so follow the slides. Devon Wei, do we need to find the p-value manually from the table when making a decision of a hypothesis test? No. We can't find p-value. Can you please explain how to do a goodness of fit test? Oh gosh, guys, what is goodness of fit? What is goodness of fit? It's overall significance F test. Okay, goodness of fit, overall significance F test. Oh no, I think it's R square, so no test on that. Well, overall significance can do that. So overall, the data fits the data, the model fits the data very well, but more likely we use R square to describe the goodness of fit, or namely how many percent of total variations in the dependent variable has been explained by the model, right? Can you explain the difference between prediction intervals and estimated intervals or confidence interval in regression? Yes, I think I've done that in the tutorials already, but if you do, for example, let's think about the father question. So when do we use confidence interval? So when we use confidence interval, we will make a prediction for all males whose father died at 83. What is their average life expectancy, right? All males whose father died at 83, average life expectancy. And for prediction interval, it's if we know a Peter whose father died at 83, what is the life expectancy of Peter, okay, of this particular person. All right. So this is the example I had in my tutorial. Okay. Again, our confidence interval is actually making a prediction on the average. Okay, it's on the means. But prediction interval is make a prediction on a particular observations. Okay. Yes, that's all. I'm so tired. Are we allowed to bring our lecture slides in the exam? Why do people keep referring to the exam as an open book? I don't know. The exam is not open book. It's a closed book. Okay? Closed book. Probably from previous semester, it says it was open book, right? But now or semi-open book. But no. Well, this unit has never been an open book before. Don't bother. It's only last semester they allow students to bring an A4 sheet. Shao Yong Wang is asking how to justify if multicollinearity exists from a correlation matrix of variables. Again, if you find a correlation larger than 0.95, it's very likely to exist. Greater than 0.9 is possible multicollinearity. Possible multicollinearity. Less than 0.9, no. Okay? No multicollinearity. I can't find the t-table in the new formula sheet. Does that mean we do not need to find those statistics in those tables? No. You still need to know the tables. That's the only reason is that I don't have the source files of those tables. And the file is so large. So when Atom sent that to me as a Word document, I cannot receive it because it's too large. So he only sent me the one without the table. So I just add the mid-semester exam formulas into that table, into the formula sheet, and upload it again without table. But still, you will be given table. What is the best way to review the content before mid? I think you already have everything is based on the previous topic. So if you really happy understand everything you learn, then you don't need to particularly look at topics before the mid-semester. But what I suggest you to do is that you really need to understand central limit theorem. Okay, this is the key thing before this mid-semester exam. And we keep applying central limit theorem for the whole semester. So or the derivation of central limit theorem for the whole semester. So the understanding of central limit theorem is very important. I'm talking about understanding, okay? It's not central limit theorem. That's not enough. You have to understand central limit theorem. Which means when n is large, no matter what the population distribution is, the sampling distribution of sample mean can always be seen as normal, okay? It's sampling distribution of sample mean, okay? The sampling distribution of sample mean, important thing should be stated 3 times, okay? What is the best way? Okay, is Aplia relevant for practice for finals? I think Aplia is sort of, Aplia really helps you to have an understanding of the topics, but the question definitely are different levels, okay? How can we analysis through the correlation matrix? Yes, you look at the correlations, right? Whether there exists 0.95 or 0.9 or less than 0.9 and see whether there exists multicollinearity. Why SST is the same for all possible linear regression for a given set of data? Because let's see, SST, what is SST? SST is equal to the observed y minus y bar square sum, right? So if you have a set of y data, does yi change? No. Does y bar change? No. So does SST change? No. So SAT will never change. It's all about whether you have x1 here, right? If you add an x2, x2 is here, but it will never change y. Y SST will only change if you take more samples, right? And then SST will definitely change. But with the same sample, SST will never change. 约清量, what's the meaning of repeated formula but with approximately in the formula sheet of some distribution theory? What is that? What are you talking about, Soli? I don't understand. I think it's my problem. Can you just restate your question? Thank you answering. Yes, it makes sense. Thanks so much for answering my question. Sleep tight. Yeah, thank you. Oh, sleep tight is really an old version. And the formula, all formula in our formula sheet will be involved in our final. Definitely no. And our exam involved tests about non-parametric? Probably yes. No sugar, no ice. I can say formula sheet is just a summarize of all formulas you've learned, right? But our test will only be testing on your randomly something, right? It's impossible to test all of them within 2.5 hours, right? Good night. Yeah, good night. Adi, thanks for your patience, Tony. You are a legend. Yes, I know. Thanks. Christy Shi, hi Tony. Why does the F test in the ANOVA hypothesis testing always one tail? For example, if being given significant, why can't we divide this by 2? Okay. So for ANOVA test, if you have read my assignment feedback, when we compare MSR and MSE, MSR is actually the between group, between treatment variance, right? Between treatment variance, and MSE is the within treatment variance. So we can only draw the conclusion of the population means are not equal if the between treatment variance, which means the between treatment variance, is greater than the within treatment variance, right? So we only look at whether MSR is greater than MSE. So that's why it's a one-tail test. We only look at whether this ratio is greater than the critical value, okay? And if MSR is very close to MSE, this means the between group variance is not that obvious compared with the within group variance. So the within group variance is also very large, right? In this way, we cannot conclude that the population means are inherently different. Those between group difference or between group variance only come from the sampling errors, okay? So this is why the F test is a one-tail test in ANOVA. That's because we only look at whether the between treatment variance is significantly larger than the within treatment variances. Okay? Courtney Wang, thanks Tony for the consultation at the upcoming Double 11 night. What do you mean that? Oh, Double 11. Oh, wow, great. Yeah, it's Double 11. Thanks a lot. You are the best tutor. I know. Thanks. Best tutor ever. Thank you. I know. Adi, will the question tell us if it follows a normal distribution? I think so. Yeah, don't worry. Or whether it's a parametric or non-parametric. I think the question will tell you explicitly because at least it's not a assignment, right? For assignment, you need to perform all of those by yourself, like whether it is normal and then which test to use, that's in your assignment. But in your exam question, they will be very specific, okay? They will tell you what to use, or they tell you if it follows normal distribution, what test you need to use or perform a statistical test, okay? Swakeda Gupta asks, in PI and CI, what values will be given in the question, or do we have to find all the values including the variance? And in the PI-CI formula, x minus x bar, what does x stand for? Any observation from data set? Yeah, x is the value that you want to predict. So it's the x value. Actually, if you test a multiple linear regression model, you will never be able to calculate CI or PI. Okay, so I think for CI PI, it's too hard to calculate. So we won't push you into that hard time. So only know the difference between CI and PI is more than enough, and you need to know PI is always wider than CI because a particular the prediction of a particular observation will be far less precise than the prediction on the average, right? Okay. Thanks for your onload, Tony. Help a lot. Thank you very much. How come CI and PI formula looks the same? Yes, they look the same. How come? I mean, yeah, the only difference is that I think it's y hat plus or minus, what is it? The t half an alpha with n minus 2 times the square root of 1 over n plus x. This is your x you want to input minus x bar square or not, I don't know, and divided by sxx. And actually, the prediction, this is confidence interval. So the prediction interval is wider because it adds a 1 over here, right? So by plussing 1, this error margin becomes wider, right? The error margin means the width, the half of the width of the prediction interval, right? Is blah blah blah, same thing, sxx, same thing, okay? So yeah, if you ask me why they look the same, yeah, they look similar, right? Thanks, Tony. Yes, will it be easier than the assignment? Yeah, as I said, it will be easier because assignment is open book, right? For open book, there must be many challenging questions because you can easily reach every single information in your books, right? Even though you probably don't have enough time to do it, but yeah, it's open book. So that's open book. When it is a closed book, sometimes it tests on your understanding rather than some challenging stuff like testing something that you never know, right? So for example, for the assignments, we try to test on using the chi-square distribution formula, right? Even though you haven't learned this before, but if you know the inverse, how inverse work, how dot this work, it's not a hard problem at all, right? So it's all about some challenging problem. But for closed book, there will be much more easier, I guess, much easier. So regression is the main thing for the final exam. Well, you can look at my new announcement. I think I was too kind to give you such detailed structure, right? So I didn't tell this. I didn't tell Autumn about this. Okay, I do this announcement first, and then tell the Autumn. You know what I mean? I just want to do good things to you. I don't want anybody to fail. You know what I mean? Okay. So look at the announcement, all right? Why is the degree freedom different for the ANOVA table for SSR? Well, I think I just illustrate the difference sometimes before. If you look back to the recording, you can see it. I just, because K has different meanings in ANOVA and the multiple linear regression. I can't find that paper. Oh, where is that paper? K has different meanings. Can anybody help me explain the difference to her? Let me, while I'm finding the formula. Oh, it's over here. Yeah, it's here. So in ANOVA, K is defined as the number of treatments. And therefore, if we want to estimate this model, we need to estimate K different mu's, right? So we need to estimate K parameters. That's why SSR have k-1 degree freedom. So it's number of parameters to estimate minus 1. But for linear regression, k means the number of independent variables. So this is the number of independent variables, but we do have k plus 1 parameters to estimate. So you can see, other than these k betas, we still have a beta 0. So you can understand it in this way. That's why our degree freedom of SSR becomes the number, again, the number of parameters to estimate minus 1. So it's k plus 1 minus 1. It's still like the number of parameters to estimate minus 1. Number of parameters is minus 1. So it becomes k. Okay? Wow, Tony, yes. Because in multiple linear regression, you need to add beta 0 in the SSR, which adds one more degree. Yes, thank you, Tan Tian. This has been explained before. You may check the video. Yes. Thanks to the user. Yes. Okay, good. Okay, great. Don't worry. Yes. So if you don't have more questions, I can go home and sleep. Oh my God. Let me drink a cup of water to push down my what? My jing, ya jing, right? Okay. All right, so finally, thank you very much for more than 100 of you watching this video. And yes, and yes, wish you the best luck in your final exams, okay? And if you got any questions, you can still comment on this video and I will check the comment, or you can comment on the ED discussion board. I will particularly look at the discussion board tomorrow, okay? Right, you can go back and buy your stuff in Alibaba. Why do you call Alibaba? Okay, fine. But I'm really hungry. I need to have some food. Okay, that's all about tonight. Thank you very much. And I think this is the last time I'm going to teach everybody. And if you do not fail this unit, right? If you fail this unit, you probably will see me again next semester. But I don't think any of you will fail, okay? I try my best to help you. And I will also be responsible for marking your or final exam. So don't worry. I will mark it very strictly. I mean very fair, okay? Okay. That's all. Bye-bye. Okay, let me end this stuff.